Good morning and welcome to another Al-Attiyah Foundation podcast. My name is Naweed Jabarkil and I'm joined today by Martin O'Neill, Vice President of Product Management at GE Gas Power and leader of the activities at GE's Centre for Decarbonization. He's worked at GE for over 10 years, split equally between the US and Europe, and has a keen interest in the developing power market, technological and commercial disruptors, and geopolitical factors that are influencing the pace of the energy transition globally. Before we start this session, I'd like to remind all of our listeners to please visit the Foundation's website at www.abhafoundation.org for the latest reports. You can also follow the Foundation on Twitter at Al-Attiyah FNDN. Now, what are we talking about today? Well, as each day passes, we draw ever closer to the 2050 deadline, when the hope of the Paris Agreement is to reduce carbon dioxide emissions so that a global temperature increase is below 2 degrees Celsius. One area that will be key to that effort is the world of industrial power. Gas turbines are one of the main producers of electrical power around the world and consequently a major source of CO2 emissions. Martin, good afternoon and welcome to an Al-Attiyah Foundation activity.
Naweed, thank you very much for the invitation. It's a pleasure to be here. Thank you.
Let's jump straight in then. With the scope of what you and the Centre for Decarbonization hope to achieve, tell us a bit about that. Are you concerned solely with things like turbine technology, or do you have a wider scope of work, such as looking into carbon capture technologies as well?
So within the General Electric company, I kind of wear two hats. Obviously leading product strategy for our portfolio of gas turbine products and combined cycle gas turbine products, also generators, steam turbine, heat recovery steam generators, the full system that's required to produce efficient electrons for our customers. With the Centre of Decarbonization, GE is really promoting and understanding that with all of the GE energy businesses in the portfolio, we are uniquely positioned to act in the energy transition. I think starting with thought leadership into technology, investment and research, into real demonstrations. I think gas turbines by themselves are not going to be this single solution for energy transition. We have to be open to the fact that renewables needs to grow as fast as possibly we can enable that. Gas is actually a force multiplier for renewables growth. We need firm capacity on the power generation grids. We need energy on demand, and the intermittent nature of solar and wind means that we have to really open our minds to a solution set which is more about integrated systems of power generation. So Centre for Decarbonization is exploring paths to combine existing GE technologies and partner with new technologies, including energy storage, carbon capture, alternative fuels and sustainable fuels, and use that broad palette of solutions to really act on carbon reduction across the globe. There will be regional nuances to solutions. There will be operator and generator policy decisions that affect that solution set. But I think GE is uniquely positioned, and the Centre for Decarbonization is certainly promoting our mission there to be a leader in the energy transition.
And you mentioned that turbines won't be the only solution, but they seem a decent starting point, perhaps looking at reducing carbon dioxide emissions in the post-combustion phase of turbine usage. Can you tell us a bit about what GE is proposing to do in that area? Will it be cost effective?
That's a very good question. I mean, the first thing to point out is that the grid needs firm capacity, and it also needs inertia from synchronous rotating resources. One of the biggest reductions in carbon intensity that's been achieved in the last decades has been through the replacement of coal with gas. So gas is already an excellent start. It has about a 50% of the emissions footprint of a comparative power output from coal. So I think that's worth underlining to start. Then the question becomes, okay, if we understand that having firm thermal capacity from gas generation is part of the solution set to help blend with and multiplying renewables, we're going to continue to need firming capacity for that intermittent resource. Then decarbonizing gas turbines becomes the top priority. And we talk about that in GE very simply. There are methods from pre-combustion, so the use of lower or zero carbon emitting fuels such as hydrogen. And then on post-combustion, that is, I would say, you've got a rich CO2 stream in the flue gas from the gas turbine exhaust. That is obviously a good place to use carbon capture technology with either liquid solvents or solid sorbents. But it's a trade-off. You need space for carbon capture systems. Right now, it's a technology, it's not in its infancy. The actual building bricks of the technology are well established, but there are further developments around the amine and liquid capture solutions and the sorbent technology that can certainly advance the capture rate of carbon capture systems. People talk generally around carbon capture in the range of 60 to 85%. At General Electric, we would like to push that number as far as we can, and at the same time have a meaningful role in better integrating existing carbon capture solutions into the combined cycle plants. Because in order to actually operate those carbon capture systems, you require energy. You need to be manipulating the flue gas, you need to be spraying, or you need to be heating and flashing off and capturing CO2. All of that costs energy, which ultimately brings down the combined cycle efficiency of the plant when there is a carbon capture system present. So the economic penalty comes in two forms. It's the cost of the capital outlay for the carbon capture system itself and its integration with the CCGT system, but then also the efficiency penalty that comes with it to operate the plant. And I think the very first steps that GE is taking is to be the competent system integrator of choice, and really to try and reduce that efficiency penalty as far as possible, whilst pushing the envelope on research into liquid and sorbent capture technologies, and really to think about how we can also reduce the footprint potentially and modularize carbon capture systems, because what we need is scale. We do believe that this is a market that will grow. It is part of the solution set for the energy transition, and we're excited about carbon capture.
And it's interesting, it jumps out at me that you talk about economic penalties or efficiency penalties, because with a lot of these things, they're usually trade-offs, aren't there? Whether that's cost, what sort of consideration is safety, do you think? If you look at, say, underground storage of carbon dioxide, is that safe? If a leakage occurs, that's going to be pretty damaging for a company the size of GE, isn't it?
I think those are good questions, and there are clearly, I would say, political concerns, there are social concerns around carbon capture. Quite frankly, like any plant, like any large engineering endeavor, this starts with some very good groundwork, some good risk assessment of the geology that you're working with. The narrative around carbon capture is not necessarily as effervescent as that around hydrogen specifically at the moment. What I would say is that since the 1970s, people have actually been capturing CO2 in depleted oil and gas fields. That technology is somewhat established, and in fact, it can even help hydrocarbon-based extraction companies, the oil and gas sector. You've probably heard a lot about enhanced oil recovery through injection of CO2 to increase reservoir pressures. I think that's a very good angle. That technique has been in use for decades. That's the first thing to note. Secondly, putting carbon back into the ground from whence it came. I think there's just a piece of simple logic there that people need to respect. And actually, having access to depleted hydrocarbon reservoirs is normally one of the best places to put carbon back into. And you even have the injection wellhead there. So the safety concerns are real. I think that good risk assessment good mitigation measures around CO2 plume tracking, local CO2 monitoring. There are very well established methods and tracking technologies available to help us mitigate those known risks. And there's actually been a lot of research published on this subject, which when you start to get into it, you see the nominal risk of CO2 capture in depleted wells. It's actually a very well-trodden path. I think what we're struggling with is generally the industry, whether it's power generation or oil and gas, getting that message out there and really influencing policy and changing or attempting to educate with respect to the social attitudes associated to sequestration specifically.
And just on that point, do you feel as though it's holding back the likes of GE, these big companies, that the public opinion on big companies like GE, even though your competitors and you are doing so much to try and clean up the world, essentially, or clean up the way you produce energy, that there's still this misconception, if you will, that about the role that you play?
I think there's a lot more education and communication necessary. Globally, carbon capture and sequestration for the world will be part of the solution in the energy transition. Locally, regionally, there are geologies in different parts of the world where carbon capture sequestration will be a much bigger piece of the solution to decarbonization and meeting net neutral commitments. So I think in the areas of the world where it really counts, we need to establish some lighthouse projects and demonstrations of safe sequestration. And we're going to need some, I think, policy support. And we're also going to need some economic incentives, carbon taxation and carbon trading, and emerging markets that will actually accelerate the adoption of carbon capture and sequestration. I think we can anticipate in the next 5 years that we'll see movements in all of that.
Yeah, and let's turn to other fuels now then. Is it easy enough to say we can swap the likes of methane with hydrogen? I mean, after all, hydrogen already used a lot in refineries. If it's blue hydrogen, then surely emissions problems are practically over for electricity generated emissions, or is it not that simple?
Conceptually, from a I would say chemical electrical conversion perspective, substituting CH4 for H2 is entirely possible. We already have turbines and classes of technology in our portfolio that have been burning low BTU synthetic gases and hydrogen all the way to 100%. There are challenges. The hydrogen molecule itself is much, much smaller in mass. The volume of gas that you need to ingest for the same amount of power output is about 3 to 4x that of CH4, of methane, natural gas. So I think, first of all, transmission and distribution of hydrogen, its safe storage. As I said, those molecules are a little bit more tricky to control in terms of sealing technologies, in terms of storage. They also drive some different mechanical properties over time. So you can see embrittlement of metals as a consequence of combusting with increased hydrogen doping in natural gas, all the way to 100%. We're deeply into research programs that will take even our most efficient H-class, our biggest H-class turbines. We can already burn up to 50% hydrogen. And we are fully engaged with various research mechanisms around the world to push that percentage as far as we can, as fast as we can. But I think we need to admit that the sheer volume of hydrogen that's going to be required is a solution that we need to be open to both blue, green, in fact, all sources of low carbon hydrogen. We need to certainly amplify their production. So when I think about I would say Qatar specifically in the Middle East region, steam methane reforming of natural gas to produce hydrogen with carbon capture to then reduce that to low carbon hydrogen, that is a path that is very exciting for us. And there are a number of studies that indicate that the actual full value stream carbon footprint of blue hydrogen is competitive with that of green hydrogen. And because you're already operating steam methane reforming plants, the CapEx outlay has already been made. The additional uptick in the economic investment to go from grey hydrogen to blue hydrogen, and then to ingest that blue hydrogen, to be honest, a gas turbine doesn't care where the hydrogen's coming from. Yeah. Right? The feasibility of combusting any source of hydrogen is entirely possible with our technology today. So I think the challenge really is, how do we amplify the production of hydrogen, low carbon hydrogen?
And you mentioned research there. Is that one area that GE is looking to ramp up? I mean, you've got this target to be net zero within the next decade, an ambitious target, and similar oil majors have targets like that. Is research crucial to this? And is that achievable, these sorts of goals?
These goals are achievable in terms of our actual installed base operation and decarbonization through substitution with hydrogen and hydrogen doping. We've been actively engaged in US Department of Energy research program as far back as 2003. We've been publishing significant research papers and creating intellectual property in this space. And we've been encapsulating those advancements into our H-class turbines and our aeroderivative products. And we have numerous proof points with more than 75 rotating assets in our installed base have already clocked up more than 6 million operating hours using syngas, hydrogen, low BTU fuels. So on that piece, we're confident. In terms of the broader GE and our own, I would say, ESG commitments for carbon neutrality, I mean, as is everybody, we're looking at our full value stream, supply chain, production, our factories and facilities, and we're using a full portfolio and spectrum of solutions to reduce our carbon footprint as fast as we certainly can.
And direct removal is something that you'd obviously be considering. I mean, a lot of people would look at this and say, if the problem of climate change is too much CO2 in the air, then direct removal might be the obvious option. Will that ever be cheap enough, do you think, without an industrial end use for that carbon dioxide? And do those technologies exist to try and do this successfully today?
I think this is an excellent question. Let's back up a little bit first. If CO2 production is what we are targeting to reduce, then the first place you start with is large-scale emitters of carbon dioxide, which would be transportation, cement, steel production, power generation, and I would say industrial processes in the production of gases, such as steam methane reforming. All of those industries have a carbon dioxide-rich emissions byproduct. So targeting them with carbon capture will give us biggest reductions quickest. And I think there is a real element of deploying the technology that we have in our hands today should be a priority. When I think about direct air capture, there are about 400 parts per million of CO2 molecules in the atmosphere in air. That is analogous, as one of my peers, industry peers at Carbon Energy describes. It's analogous to trying to extract a drop of ink from a swimming pool full of water. That's what 400 ppm looks like. So the space, the air that you need to ingest, process in order to drive the capture of 400 ppm, that is a very interesting balance to try and achieve when you think about the scale of the actual mechanisms that you need. I'm encouraged by many of the, I would say, not startups now, but seedling solutions that we're seeing around the world, but they tend to be somewhat niche, those solutions. I think what's an interesting path from a product strategy perspective, to be somewhat local, is carbon capture and sequestration and the technology advancements that we need there in liquid and solid absorbance and capture media, and how you can translate and scale those advancements into direct air capture. So that's certainly a focus of research at GE. We are interested in direct air capture. It's certainly not lost on the General Electric company and myself personally that direct air capture allows you to achieve a negative carbon position rather than neutral, and it helps to really offset some of those difficult to decarbonize technologies. I think that's why it's getting a lot of media attention and coverage, and it's attractive to many people. It makes sense, tops down. But I think in order to get to the economic scaling point, we really need to push the technology within the direct air capture systems, which is analogous to the carbon capture and sequestration systems that we were talking to at the top of this conversation.
Yeah, and I'm conscious of time as we begin to wind down, no pun intended. I want to turn briefly to wind power. GE now producing the largest wind turbines anywhere in the world. They're going to use them here in the UK on the Dogger Bank project. How important is wind power for GE?
Wind power is hugely important for GE, whether it's onshore, offshore, as is our photovoltaic portfolio and all of the grid technology that connects that. We really believe that there's going to be massive growth in renewables, and the offshore wind can be a huge part of that. The Haliade X, which is our largest 13 megawatt offshore wind turbine, is a testament to the brilliance of the GE engineers and our desire and will to compete and win in that market. Ultimately, all of that renewables growth needs firming capacity. So, as I've pointed out repeatedly, we need to think really of a broad palette solution set for the energy transition. So, gas with renewables and gas as a force multiplier for renewables. That really is the position from the top of the house in the General Electric company and the energy transition. But we are super excited about renewables growth, and we intend to be a market leader and a technology advancer in that space.
And I just wanted to wind the conversation down by talking about the Middle East and Qatar in particular. GE has been in Qatar for a long, long time, large fleets of industrial turbines there as well. By some counts, they emit over 50 million tons of carbon dioxide. How can Qatar, a country like Qatar, reduce these particular emissions, do you think, in the short term, in the medium term?
More than 100 rotating assets, gas turbines in Qatar with GE technology. And really, the first thing that we can do is deploy the solutions in our hands, which is make those units operate as efficiently as possible when you fundamentally burn less fuel to achieve the same or improved power output. That's real efficiency. And with that efficiency comes a compensating CO2 reduction. So you talked about 50 million tons per year. If we were able to just push the efficiency of those 100 assets by 1%, you could reduce that immediately by 2% of the CO2 output. So that's a good start, and those solution sets are in our hand. Then in terms of carbon capture, I think planting a flag in a country where the geology certainly works in our favor with carbon capture and sequestration, where there's a real economic argument with oil recovery methods and CO2 injection and wellhead injection. And then ultimately, Qatar has the resources to produce a lot of blue hydrogen, low carbon hydrogen. So I think the solution set is operate what you have as efficiently as possible. Think seriously about carbon capture and sequestration, as much for steam methane reforming and hydrogen production as for the power generation itself. And then as a consequence of that activity, you have low carbon hydrogen, and we can increasingly dope hydrogen into the natural gas supply of those turbines. You're building a solution set that can walk you down from today's carbon emissions. You can cut that by more than half in within a decade. But there's a question of economic viability, policy, and incentive that needs to be addressed, and that's going to be a local discussion. What is great about the geography of Qatar is the proximity. You have all of the solution set, you have the entire palette in your hand, and the distances between injection wells, production power generation, SMR plants are somewhat localized. So the ability to build clusters that are increasingly working towards net neutral, I really think that there is a good story here. And I really hope that GE is active in the solution set in Qatar, because I think there is great potential here.
And just lastly, I'm going to finish in the minute or so we have left, Martin, with a simple question, but maybe a philosophical one that might be difficult to answer. But we started talking about that goal of 2 degrees Celsius. In your opinion, COP26 this year, a crucial year for global emissions and that target, what do you think is the single most important thing from your perspective if the world is to reach that target?
I think serious commitments to deploy the solution set we have today whilst we mature and scale technologies for the future. I think we need to be as excited and as ferocious around blue hydrogen and carbon capture as perhaps the narrative is on green hydrogen. And I think that perhaps some of the colors of hydrogen are not necessarily helpful, and that we need to all be thinking about what is the solution set to generate low carbon hydrogen as soon as possible, and use that increasingly in power generation, and how do we really enable carbon capture. We have a lot of, I would say, thought leadership materials on all of these subjects, and a complementary podcast series called Cutting Carbon, which I would hope that some of your listeners would be interested to listen to. And we've also published a suite of white papers on methane, on hydrogen production, but also hydrogen usage in gas turbines, and also carbon capture. We really want the technology solution set in our hand today needs to be deployed and scaled as fast as possible if we're going to hit those targets in 2035 and 2050.
Excellent. Thank you so much, Martin, for sharing your views with us on the whole range of interesting subjects. I think that's all we have time for. For our listeners, watch this space for the next Al-Attiyah podcast in the series. I'm Naweed Jabarkil. Thank you and goodbye.